All right, Mr. Antonucci here, and we're going to talk about how to perform a chi-square test for homogeneity. So another common situation that leads to a two-way table is when we compare the distributions of a single categorical variable for multiple populations or treatments. So let's take a peek at an example here. Does background music influence what customers buy? One experiment in a European restaurant compared three randomly assigned treatments: no music, French accordion music, Italian string music. Under each condition, the researchers recorded the number of customers who ordered French, Italian, and other entrees. The two-way table summarizes the data from this experiment. And so here's how we would actually state these hypotheses. There is no difference in the true distribution of entrees ordered at this restaurant when no music, French accordion, or Italian string music is played. Notice the null is the dull, no difference. This is different than the chi-square test for independence. Here, this is not looking for an association. We're looking for a difference or no difference in the distribution. So the alternative would be the same exact sentence, except there is a difference. So just be careful there with that. Now, the alternative hypothesis does not state that all of the distributions are different. Instead, the alternative hypothesis is true even if just one of the true distributions is different from the other. So we're just going to real quick go through the four-step process for how to set all of this up. First thing, check the conditions. You have the random 10% and large count condition. But here in this experiment, the random condition is meant because researchers randomly assigned the three treatments. We don't need to check the 10% condition because the customers in the experiment weren't selected without replacement from a population. But for the large counts condition, we do need to calculate the expected counts, and those are calculated the same way. Row total times column total divided by table total. So if we looked at that, we would get this table of expected counts. Again, remember, you can either produce this as a separate table or write it in the given table in parentheses, either next to or below each particular cell value, and then just indicate with a sentence saying values in the percent in the parentheses are expected counts. So here is the expected counts. Again, don't round those to an integer. Make sure you go out at least one or two decimal places. The test statistic and p-value are again calculated the same way. Chi-square is just observed minus expected squared over expected. And degrees of freedom is number of rows minus 1 times number of columns minus 1. Now, here is the four-step process for the chi-square test for homogeneity. Again, this one, the homogeneity one, is a significance test of the null hypothesis that there is no difference in the distribution of a categorical variable in the population of interest or treatments in an experiment. So let's look through an example and go through the whole four-step process. Pew Research Center conducts surveys about a variety of topics in many different countries. One such survey investigated how residents of different countries feel about the importance of speaking the national language. 13 independent random samples of adult residents of Australia, the United Kingdom, the United States were asked, how important do you think it is to be able to speak English? And here we have a two-way table of the results. Question, do these data provide convincing evidence at the 0.05 significance level that the distributions of opinion about speaking English differ for residents of Australia, the UK, and the US? So let's go ahead and look at our example here and conduct the four-step process. State there is no difference in the population distributions of opinion about speaking English for residents of Australia, the UK, and the US. And the alternative would be the same exact wording, except there is a difference. So that's the alternative hypothesis there. And remember, we're going to state our significance level in the state step. In the plan step, make sure the first thing we do before we check the conditions is say what we're checking the conditions for. State the procedure we're using. Here it's a chi-square test for homogeneity. So three conditions, random. independent random sample of adult residents from the three countries. Notice it's independent random samples, not just sample, because up here it said we did 13 independent random samples. And then the 10% condition, um, the totals for the three countries, it makes sense that all three of those totals are less than 10% of all the residents in those three respective countries. And then for the large counts condition, we want to make sure that we have the expected counts somewhere. So here we made a table of expected counts, and then we can just say that all expected counts are at least 5. Again, you have to explicitly include the expected counts in your 4-step process. Now, moving on to the do step, you can do this with the full technology approach, all on the calculator, but make sure you write the values down. So for the chi-square, it's 68.57. The p-value is 6 because we have 4 rows, 3 columns. Subtract 1 from each of those and multiply, you get 6. We drew the chi-square distribution here with 6 degrees of freedom. Our chi-square value 68.57 is way up here. And the p-value is the probability of getting a result that high or higher if the null were true. So the p-value is 0.0005, and we have the c value, or excuse me, the p-value from table C was 0.0005. Sorry, I misspoke. It's less than 0.0005. The p-value from the technology approach is going to give us approximately 0. Now I'm showing both of them here, but you don't have to get both of them. I would recommend just using the calculator p-value, but just wanted to have the table value to show you how to report that. Now we're ready for our conclusion. Because the p-value of approximately 0 is less than our significance level of 0.05, we reject the null. There is convincing evidence of a difference in the population distributions of opinion about speaking English for residents of Australia, the UK, and the US. Notice this doesn't tell us what the difference is, or even if it's a specific country. It just says we have evidence that a difference exists. So there it is. There's our 4-step process. Notice we didn't have to do any follow-up analysis as part of the 4-step process, and we weren't asked to do any, so we don't have to do any. Now, an AP exam tip is many students lose credit on the AP Stats exam because they don't write down and label the expected counts in their response. Remember, it isn't enough to just claim that all expected counts are at least 5. You have to provide clear evidence with all the expected counts to support that claim. Now, as we wrap up this piece right here, we do have 3 different tests that use chi-square test statistic. So it's important to know how to make the distinction between each of the 3 and when to use each one. So the first one we talked about was chi-square goodness of fit. That is going to be used when you have 1 sample, 1 variable, and 1 population. So it's categorical variable in this case. The chi-square test for independence, again, you have 1 sample, but 2 variables and only 1 population. Again, categorical variable. The third is test for homogeneity. This is where you might have 2 or more samples or groups, if it's an experiment, 1 variable, and 2 or more populations or treatments. That's where you use the chi-square for homogeneity. All right, guys, that's it for this one. Hope that was helpful to you.